Assalamu alaikum and very good morning to all of you. Today in the grade 8 in the subject physics we are going to continue our lesson from the chapter 36, that is electromagnetic induction. Here in this chapter we are going to continue from the page 297. So please open the page 297 and let's continue the lesson from this page. So here, what are the learning objectives in the today's lesson that we are going to see here? The objectives for the today's lesson, that is the Faraday's law of electromagnetic induction, how does it work, that we will be going to see here, and also the another law, that is Lenz law with the direction of current, how does it work with the direction of current, that we are going to see here. For the first, that is about the Faraday's law, what the Faraday law is saying. Now here already we have discussed about this. For the Faraday law, that this is the electric coil here, or we can say the loop of the wire is here, and here the galvanometer is arranged for it. Also here the bar magnet is here with the directions, that is north and south direction, and the direction of the movement. When you are moving this electromagnet, what will be the its effect, that we are going to see here. So now here what the Faraday law says, that when the Faraday's law states that a current will be induced in a conductor which is exposed to a changing magnetic field. What does it says? It says that that the current will be induced in a conductor which is exposed to a changing magnetic field. And also we can it is observed that from the Faraday found that the induced voltage can be increased by following things. That is, first thing is about the using a stronger magnet. The secondly, we can increase it by moving the magnet faster, and the third thing, that is increasing the number of turns on the coil. So if you increase the number of turns on the coil, it means that the current will be increased, the voltage can be increased by these ways. So first thing what we see, that when the Faraday is saying that the induced voltage can be increased by stronger magnet, and secondly that when you are moving the magnet faster, then also there will be the induced voltage will be increased, and the third thing, that is the increasing the number of turns on the coil will increase the induced current or voltage. So now here furthermore, when we are talking about the current, how does it work, and here if you see that the magnet which is moving in here in this diagram, here the south pole, here the north pole, and this is the current flow with the connected with the galvanometer. It is shown here in this diagram. Here is no movement in the magnet, it is shown, and in the third diagram which is shown that when it is in the coming out, going out away from the this current flow of the diagram which is showing here, where you can see the galvanometer is indicating the current in the opposite way. So now here let's talk about the Lenz law. What does it says? Lenz law states that the direction of this induced current will be such that the magnetic field created by the induced current opposes the initial changing magnetic field which produced it. So here it is saying that it will be induced current will be such that the magnetic field created by the induced current opposes the initial changing magnetic field which produced it. So this is about the direction of the Lenz law. Lenz law, according to this Lenz law, as we have seen this diagram where these currents, and where you are finding that when N pole, that is the north pole of the bar magnet, is moving in, the current flows so as to produce the N pole at that end of the coil, and this means that the current is opposing the movement of the magnet. And in the other way we can say that when the north pole moves out, the current flows the way other way, that is to make a S pole again opposes the movement that is trying to attract the magnet. Here it is trying to attract the magnet when it is in the opposite direction. So when there is a N pole moves out, then it is attracting the S pole, and when there is S pole, when there is the north pole, it is attracting the S pole. So it is having the attraction as well as repulsion here in this. So here if you are moving in, there is repulsion in them, because here is the north pole and here also it makes the north, whereas this is the north pole and here it makes the south when the current is flowing here, and you can see the current flows in the way the needle it shows. Here it shows in the opposite direction, so here it shows in the same direction. So this is the way that we can say that there is the flow of current in this. And also with this kind of induced current are also used in moving coil and moving coil of microphones. Also it is used in the tape recorders, video recorders, and also we have seen that hard disk of computers also it is being used. So this is the way that one singer, it is shown in the diagram that singers rely on induced current in a microphone. So this we are going to discuss about this particularly microphone in further part of the lesson, and till then I will be going to conclude here the lesson, today's lesson, and we will be back with the new video and we will be going to continue the lesson. Till then, thank you and goodbye.